In this video, I'm going to look at conservation of energy and when you're considering energy, the need for a very clear start and end point. So you may well have come across the law of conservation of energy already, and a little clue to remind you is this word conservation, which you may have come across in other contexts as well. So have a think if you can remember what is meant by conservation of energy. Okay, hopefully you have remembered or realised that conservation of energy says that energy can be stored or shifted between stores or dissipated, which means spread into the surroundings. But energy cannot be made or destroyed. And it's worth noting that every time energy transfers or shifts, the energy is dissipated or spreads out, so it is then less useful. And largely this is because some of it ends up in the internal or thermal store of the surroundings. And that's why it's bad if you leave a light on when you don't need it, as the energy is then shifted into the internal or thermal store of the surroundings, and we can't then use it for further useful things. So conservation of energy is very useful as it allows us to predict and calculate things, which is really the whole point of thinking about energy in the first place. This table gives us a useful summary of what we might predict or calculate using the different energy stores. So first of all, if we think about kinetic, that might allow us to predict how fast something's going. If we think about gravitational potential, that might allow us to work out how high something would get. Thinking about chemical, that might allow us to calculate how much fuel is going to be used for a journey, or it might allow us to calculate how long an iPad or iPhone battery might last. Internal or thermal might allow us to calculate the temperature of something or how long it would take to melt something. Elastic potential could allow us to calculate how much something stretches or compresses. And electrostatic, magnetic and nuclear could allow us to calculate those things, but that's really going to be beyond the scope of Key Stage 3 and GCSE. So I'd like you to now think about throwing a tennis ball vertically up. So if I throw a tennis ball vertically up and watch it bounce, afterwards, what energy stores of what are relevant and how does energy transfer between the stores? So I'm imagining that the tennis ball gets thrown up, it goes up, changes direction, comes down, bounces on the ground and then goes up again. I'd like you to think about how does energy transfer between the stores of what during this process. Pause the video and have a think about that now. Now that you've had a chance to think about that, I'm going to review it, and I'm going to review it, and whilst I do, I'm going to have the object in red in the writing and the energy store in purple to make it clear that I'm at each stage discussing the energy store and of what object. Okay, so I might say that before throwing there is lots of energy in the chemical store of my arm. As I move my arm muscles, energy transfers from the chemical store of my arm to the kinetic store of my arm and to the kinetic store of the ball. After the ball has left my hand, energy transfers from the kinetic store of the ball to the gravitational potential store of the ball, and that's why the ball is slowing down as it moves up, and at the top of its flight, the highest point it gets to, all the energy has transferred to the gravitational potential store of the ball, and at that moment the ball instantaneously stops as it changes direction. As the ball moves down again, energy transfers from the gravitational potential store of the ball to the kinetic store of the ball, and the ball gets faster. When the ball hits the ground, it momentarily stops and changes shape, and all the energy is transferred from the kinetic store of the ball to the elastic potential store of the ball, and some into the internal thermal store of the ball underground. As the ball leaves the ground, it returns to its original shape, and the energy in the ball's elastic potential store is transferred back to the ball's kinetic store. However, some energy remains in the thermal store of the ball and ground, so it doesn't get back to its original height, as there's less energy to transfer from the kinetic store of the ball to the gravitational potential store of the ball. Now, you might even have included more energy stores if you'd worried about the force of air resistance, which would have caused more energy to transfer into the thermal or internal store of the surroundings. But this isn't a useful discussion that we've got here, and the reason for that is there is one major problem, that we have not chosen a clear end and start point. So we've got something very complicated and not very useful. So what is essential to learn from this is that when we're talking about energy, we need a very clear start and end point, and then that will make things much simpler for us. Okay, so in this video we introduced the concept of conservation of energy, and we have also seen that it is very important to have a clear start and end point to avoid getting a very complicated discussion, which is not very useful.